So once again, if I switch to this diagram, if I wanted to get the substring of those three characters, what I need to do is that I need to specify the position of the first character when I'm extracting my substring right here, the position of the first character, and then I need to specify the position of the character one beyond the last one that I want to include, right? So we can say that in case if this is the entire string, it actually points. If I wanted to extract this entire section, this substring, right? This entire substring from the string, I would have to specify the beginning position, which is kind of easy, but then this is pointing to the position of a non-existing character, right? So this is how substrings are extracted based on character ranges. There's actually a name for this type of range. It's called half-open range, because just like in geometry, you can have a segment, right, which excludes, sometimes may include, sometimes may exclude the ending points, right? So if the ending point is included, and the beginning point is included, and then the ending point is excluded in this segment. In geometry, you would, if this was like A and B segment in your geometry book, this segment would then be written as in the notation would be written as A is included in the segment, whereas B is excluded, which is using the rounding parentheses. And in software, those are very popular types of ranges, and they are referred to as half-open range. Okay, just like in geometry, because the idea is pretty much the same. Like use all of this except that ending point. Okay, and then of course, because of this mess at the end, to spare you from doing hard work, if you want to specify the beginning position and go all the way through the entire content through the end of it, then you just use an overloaded version of this substring method, which basically just asks you for the initial position. In other words, this statement will also work if I just said this, right? Just not even use the second parameter. Instead, just say position 0 through the end, and the two statements here are equivalent. All right, moving on. We mentioned that the string builder is using an internal buffer to store the content, which does in its size does not match the length of the actual content, and that's why we have the capacity. So the capacity of the string builder, if you keep appending to it, or if you keep inserting or replacing substrings with bigger substrings, so the content grows in size, then obviously the initial size of your memory buffer will be expanding and growing and growing. So the initial memory buffer size is going to run out of space, and it needs to be reallocated. So this sample here, this kind of sample here, creates a string builder with which uses the new operator and, of course, the parameter, the initial parameter. So sometimes to avoid unnecessary reallocation of the buffer, it's possible to use this constructor to initialize the object with a specific internal buffer size. So this one, as you can see, yields capacity 8 because I said I want the string builder with this specific capacity. And that's the type of constructor that you have that you can pre-allocate the buffer. All right, so we get this capacity, which again gives you not the length of the content, but rather. And then we say append, and this is kind of longer string than 8 characters. So then, in fact, the length of the content is 17, but the capacity has grown to 18. And this is sort of like a formula which you can find in Java documentation. The ways to grow the buffer is basically it gets multiplied by 2. What's it? So this is the formula. Current capacity times 2 plus 2. This is what the string builder documentation tells you. In many cases, it's not important, but if you think about why would you use string builder as opposed to a regular string, well, perhaps you're starting to think about efficiency. And of course, memory allocation and reallocation is expensive operation because memory management is not just saying, oh, give me a block of memory. There is a memory manager which keeps a list of everything that's available in memory, and it's oftentimes organized like a balanced tree of things. It has an index to the memory that's available and specifies the sizes and everything. And working with that memory manager is an expensive operation because it does a number of things before it will give you chunk of memory. So string builder, in the first place, this is where you say, instead of reallocating unconditionally when I want to change my string, I use the string builder. So therefore, the capacity is part of that memory management, right? So if you anticipate your string to grow to a certain size, it's natural to think about the initial capacity and allocate that allocate that capacity beforehand, even before the actual content is populated.